Triassic mass extinction. In fact, every one of the big mass extinctions, except that at the end of the Cretaceous, is dominated by one of these flood basalts. If we look and see these around the Earth, every one of these patches, these big red patches, shows the area, the extent that the lava spread out. And the largest of all is 250 million years ago. But we again have ages that are considerably similar to those of the other mass extinctions. So if not impact at the end of the Devonian, because we can find no evidence of impact there, no evidence in the Permian, what was it? And in 2005, a scientist who was funded by the NASA Astrobiology Institute of Carl Pilcher, as I was in all this work, and I should acknowledge the funding of this, came up with a radical idea. What about hydrogen sulfide? Hydrogen sulfide is a terrible stuff. If you've had a great, wonderful meal with beans, several hours later, you are in hydrogen sulfide. Need I say more? Let's just say if we get eggs and let them rot, hydrogen sulfide. We are so capable of detecting levels of this in a few parts per million because this is really dangerous stuff. And Comp suggested that hydrogen sulfide was actually what killed off all the stuff at the end of the Permian, at the end of the Devonian, and that it comes up in a series of waves, and that this is related entirely to these volcanic provinces. Well, this is confusing. How could volcanoes produce hydrogen sulfide? Where are beans in the mix? Let's think about how the world works. Right now, we've got this cloudy day. We're at the equator. Elsewhere in the equator, it's extremely hot, and I'll tell you right now, down in Antarctica, where I've been working the last 3 years, it's extremely cold. That cold in Antarctica, that hot up here, causes currents. Currents in the ocean, currents in the atmosphere. What would happen if we had global warming to the extent that the North and South Pole were the same temperature as the equator? What happens to wind? Goes away. What happens to ocean currents? Goes away. What would happen if all of a sudden we had a volcanic explosion that produced so much carbon dioxide, up to 3,000 or 4,000 parts per million, that we heated our planet to that point? The thing about global warming, the tropics are as warm as they can be. You can't make them much warmer. But the poles, you can make a whole bunch warmer. Right now we're seeing this. We're seeing rapid and huge temperature changes at the North Pole, the South Pole, and virtually nothing at the equator because of the physics. But that is creating in our modern day situations that happened in the past. At the end of the Permian, in the Devonian, these volcanic episodes